Hi everyone. I am Haoxin Li from Nanyang Technological University. I am presenting the work mitigating and evaluating static bias of action representations in the background and the foreground. This is a joint work with Yuan Liu, Hanwang Zhang and Boyang Li. The action representations are learned by a deep neural network with pairs of video and action label. The representations work well on IID videos but fail to generalize to OOD videos. The reason for the failure is static bias of representations. We first ask where the static bias is from. It is well known that background bias leads to wrong prediction when a typical background is shown, such as predicting juggling soccer when a soccer field is shown. But foreground static bias has been underexplored. The examples include guitar for guitar playing. Guitars could appear in a video but is not being played. But the models may wrongly predict playing guitar due to the appearance of guitars. To investigate the existence of foreground static bias, we create test videos with conflicting action cues from the moving part and the static part of the video. We first replace the background of an IID video by a sinusoidal stripe image. Then we extract a foreground from one frame in another video and insert the static foreground into all the frames of the video obtained in the first step. The resultant video has meaningless background, so the action information must come from the foreground. The foreground contains two action features, a static one and a moving one indicating different action labels. This design allows the quantification of foreground static bias. Our evaluation showed that vanilla action recognition methods and background bias mitigation techniques could not mitigate foreground bias, showing the existence of foreground static bias. To quantitatively evaluate and pinpoint the static bias in the background and the foreground, we create two benchmarks, SCUBA and SCUFO. By replacing the background of an IID test video, we obtain a SCUBA video, on which high accuracy indicates weak background static bias. By selecting one frame and tile it temporally into a static video, we obtain a SCUFO video with zero motion but identical static foreground in the corresponding SCUBA video. The action information must come from the static foreground. So that low accuracy indicate weak foreground static bias. To mitigate static bias in both the background and the foreground, we propose still mix. First we randomly sample one frame from a video and train a 2D reference network with the label of the video, so that the reference network learns the correlations between static frames and action classes. Second we use the 2D reference network to identify frames with high prediction probabilities to construct a biased frame bank. So the biased frames contain distinguishing static features. Third we randomly sample one frame from the biased frame bank and tile it temporally into a static video, which is pixel-wisely mixed with a given original video. The action label of the mixed video is kept as the same as the given original video. Then the pair of mixed video and the action label is used to train a 3D main network. Since the labels of the mixed video and the original video are the same, the 3D main network is discouraged to learn the correlation between action classes and biased frames, including backgrounds and foregrounds, enabling mitigation of both types of static bias. We explain why stillmix works from the perspective of OOD generalization. OOD generalization attempts to learn invariant predictors F* that work well in all environments. It optimizes the loss on the worst environment to achieve the invariance. Stillmix mixes a video Xi with a frame Z biased into a new video Xi tilde. Z biased is sampled by the reference network, so it contains static features biasing predictions toward specific classes, which could be regarded as coming from an environment E'. Mixing Z biased with Xi simulates sampling the video Xi tilde from the environment E'. By randomly sampling Z biased, stillmix optimizes the loss on all environments, which replaces the maximization with an expectation. So that it could be considered as a variant of OOD generalization. Our experiments showed that stillmix mitigates foreground and background static bias. It showed comparable results on IID videos and SCUBA videos but much better performance on SCUFO videos, contrastive accuracy and videos with conflicting foreground cues. These results illustrate its capability to mitigate static bias, especially the foreground's bias. Stillmix also improves representation learning. It outperforms other methods on transferring action representations across datasets. The learned action representations improves the performance of weakly supervised action localization. Our ablation study illustrates the characteristics of stillmix. Debiasing works the best when the reference network and the main network share the same architecture. Sampling biased frames improves debiasing compared to random sampling. Thank you for your attention.